Okay, so our video today is going to be talking about Unit 2.4, Day 6, and this is what we call compositions of functions. Now what we're going to be doing is we're going to still be working with functions, but we're going to look at what it means to be a composition. We can kind of look at definitions of words to understand what a composition might be, but the idea is that we're going to do this with functions and using kind of our algebra skills. So the first thing that we want to do is we want to state our objectives. So we're going to evaluate a composition of two or more polynomial functions using our order of operations, or PEMDAS, and the properties of exponents. So we're going to look at everything that we've kind of done so far and kind of be able to compose two different functions using our order of operations and some of the other exponent rules and other things that we've done so far. So when we start with the basics, what we have to kind of look at first is that we have to understand that first, this is what we call function notation. Now we have to understand that this is no different than y equals, but at some point in algebra what we learned is the difference between a relationship and a function. And so when we talk about functions, we always use this f of x, where this tells us a couple of different things. This is kind of the function name is just the f, and then the x kind of tells us what variable that we would be working with. And if I tell you for x equals 3, I want to know the value of this function. And so the first thing that we would always do is we would always substitute. And so that's going to be the same thing. And so when we start with these basics, we would substitute x equals 3. And so we would take 3 and substitute it anywhere we see x. But if we're going to write this with function notation, we always want to write this f of 3. Now when I say f of 3, basically what that means is the function evaluated at 3. So what that tells me is I substituted 3 for where x is, so that means everywhere I see x, I'm going to put a 3. So with that being said, I'm going to put a 3 here, so this is 2 times 3 squared plus 3 times 3, and then subtract 1. Now my second step was pretty easy, and what we would do is we would just simplify. And we would simplify using our order of operations. So we make sure that we use our PEMDAS or our order of operations. And then we go through this and we get 2 times 9 plus 9 minus 1. And we get 18 plus 9 minus 1. And so what that means is that f of 3, the function evaluated at 3, gives me 26. And so this is the way that we want to write it. So we were writing it f of 3 equals 26. Now the reason that we're doing that is because we want to look at this function notation and how we can use it. Which brings us to what we're going to be talking about. And what is a composition? A composition of a function g, we're just going to call it g. It's not that it has to be g, it's just a name that we're going to use. With a function of f is written g of f. And so when I write that, g of f. So this is a composition of functions, and it's defined by the following. So we kind of have this parentheses g of x parentheses x, which means that this is another way that we can write this, where we call it kind of a nested function, where you see f of x is inside of g of x. And so the domain is all the values that are the values of f of a in the domain of g. Basically, a long story short is that we're just making sure that we're using all the same values, that any value that I put in the function f means the function g. Now, the way that I would do this is if we look at this, this is kind of nested, where you have one function inside of the other. And so from what we've just seen f of 3, and so that means take the value of 3 and plug it into my function. Where this one right here, if you notice that this is kind of put together, what we're going to do is we're going to find the value of 3 of f, and then we're going to take that value and plug it into g. So this is just kind of a composition. So you find f of 3, get an answer, and that value goes into g. And so it's kind of a way of just kind of making two functions work simultaneously and getting to see where they can kind of have the same value, or kind of working one after the other. Well, we're going to see what those look like so we can get a better understanding of what's actually happening. So let's look at these two functions. So the first one, we have f of x, so here's a first function, is 2x plus 3, and we have g of x, which is negative x squared plus 5. And so what we're going to be tasked to finding is we're going to be tasked to finding g of f of 1. So this is g of f of 1. Now, this seems like a lot of work, but the idea is that we're going to start from the inside of this kind of nested function to the outside. So the first thing that we're going to do is we're going to evaluate the inner function. Our inner function is f of 1. And so f of 1 means that I'm going to use the function f, and anywhere that I see x, I'm going to plug in 1. So 2 times 1 plus 3. And so the function of f evaluated at 1 is simply just 5. Now, with that being said, I'm going to take that answer and substitute it into the outer function. And so I'm going to take this piece of it right here is equal to 5. And so, in other words, g of f of 1 is no different than saying g of 5. Because the whole idea is that I evaluated f, and I got a value of 5, and now I'm going to plug that into my function of g, which is on the outside, and get the same value. So I'm just going to basically plug in 5, so negative 5 squared plus 5. Make sure that I follow my order of operations. I get negative 25 plus 5, and so g of 5 is equal to negative 20. Now, because that's not really what I'm finding, I'm not really finding g of 5, but what I want to find is g of f of 1 is equal to negative 20. So after I've plugged all that stuff in and I've kind of followed that chain of command, I get negative 20. So it's just kind of an idea of substituting one function into the other. Now, we want to see if these values would be the same if they're reversed. And so now, if we look at what we're doing f of g of 1. So this time, we're evaluating g first at 1, and then plugging that answer into f to see if we're going to get the same result. So we're still using the same two functions, so f of x and g of x. And so first of all, we're going to evaluate the inner function. So g at 1. And so g of 1 is basically negative 1 in parentheses squared plus 5, and so g of 1 is negative 1 plus 5, and so g of 1 equals positive 4. Now I'm going to take that value, and I'm going to find f of g of 1. And so again, this is kind of the same thing as just doing f of 4, but realistically we want to write this as f of g of 1, but understanding that we're going to substitute 4 into our function. And so we're going to take 2, multiply it by 4, and add 3. And so f of g of 1 is going to be, that's 8 plus 3, which is 11. So notice that we don't get the same answer when we reverse these, but the idea behind it is that we're just working from the inside function to the outside function and kind of just carrying those values along with us as we move from one function to the next. Now, we can use the same function more than once. And so in this situation, what we're doing is we're working with exactly the same two functions that we've been working with so far. And the whole idea behind this is we just have to understand that it doesn't matter which functions that we compose with other functions, as long as we're just following the same rule in which we're working from the inside to the outside and just kind of carrying along those functions as we go. So in these situations, see if you can try to go ahead and do these, and then I'll go ahead and do these in just a second. But the idea is that we can manipulate the same function more than once and just kind of keep cranking out these different values as we go along. So try f of 1 and g of 2 in this situation. Okay, so I'm going to start from the inside out, and we can start with f of x, which is 2x plus 3, so this would be 2 times 1, whoops, that's a 1, not an x, so 2 times 1 plus 3, so that's f of 1, and so f of 1 is equal to 5. And so I'm going to take that 5 and plug it back into f again. So f of 1 is going to make me substitute in 5. And so that gives me 2 times 5 plus 3. And so f of 1 is going to give me 13. So the idea, again, we can still use the same function more than once as long as we're just following the rule. Now with this one, I take g of 2, and I'm going to plug that in. And so I get negative 4 plus 5. And so g of 2 is equal to positive 1. And then g of 2 is going to have me plug in 1 because that is the answer to my g of 2. So if I was to kind of just erase that and say g of 2 is really just 1, that's the same idea. So we're just carrying this value forward. But instead we want to make sure that we're writing it as that composition. So g of 2. So now I'm plugging in 1 again. So negative 1 squared plus 5 gives me g of 2 as an answer of positive 4. And so the idea is just following the rule from working from the inside function to the outside function and just carrying those values forward. Now, like all great algebra problems, what we're going to want to do now is we want to remove the numbers and not actually plug in values in order to find these compositions of functions. Because what we want to do is we want to kind of generate a new function and kind of generate a new rule so that anytime I tell you to plug in a particular value of x, then it's going to just kind of carry over and we'll understand what we're going to find and we can kind of skip those intermediate steps. And so what we're going to do is we're going to follow the same process that we have been, and we're going to plug the inner function into the outer function. So if I give you two equations, we have f of x and we have g of x. We want to find f of g of x. So this is f of g of x. So we want to find the value of the function if we have these two be our composition. And so what that means is I'm going to plug my inner function into my outer function. Now that gave you this hint because if you remember back from Algebra 1, you solved systems of equations and you plugged one equation into the other equation. And that's really simply what we're going to be doing. We just have to be very careful with how we go about this so that we don't make any mistakes as far as order of operations. And so using parentheses is going to be a big part of what we're going to do. So use parentheses. And so what I'm basically going to do is I'm going to start with the inner function and plug the inner function into the outer function. So f of g of x is going to look like this. So g of x is my function, and so inside of f of x I'm going to be plugging in x squared because g of x is x squared. So in my function of f, everywhere that I see an x, I'm going to plug in x squared using parentheses. So if my original function of f is x plus 2, that's what I started with, everywhere that I see x, so right here, I'm going to erase that and I'm going to plug in x squared. Now notice that I put in parentheses, not very good parentheses, but if I have x squared in parentheses, so notice that I put in parentheses the x squared because if there was anything on the outside of that, whether it was other exponents, whether it was coefficients, I would have to multiply or do anything else that I needed to do in order to simplify that. And so basically what I'm going to make sure that I do is I have that in place. And so f of g of x is simply x squared plus 2. I plugged in one function into the other. So let's look at one more function, or one more composition. We have f of g of x. Now in this situation, I have two new functions, so I have 4x plus 2 and I have x plus 2. I'm going to plug the inner function into the outer function. So my composition looks like this. F of g of x. And so if I look at my functions, I'm going to plug in g of x into f of x. So in other words, f of x, or g of x, I'm going to substitute that, and g of x is simply x squared. And so anywhere in the function f that I see x, I'm going to plug in x squared. So f of x is 4x plus 2, that's my original function, and anywhere that I see x, so right here, I'm going to plug in an x squared. So instead of simply just making that x a squared, I'm going to substitute in x squared in parentheses. Now I'm going to follow my order of operations and I'm going to get the following function, 4x squared plus 2. Now it's not as easy as just putting a squared there, so I understand that if you think about that and then it was like, oh, it's just x squared now, That's not necessarily how it's going to work. We're going to look at some other situations that we have in class, but the idea behind this is that you're taking one function and just plugging it into the other function. Notice the steps that I made. I made the step here of just taking this function and just rewriting it as whatever that expression is, so whatever that equation is that I'm going to use, and then I'm going to plug that into my outer function and just substitute and use my order of operations. Okay, so kind of in conclusion, we kind of have to look at this notation for our compositions of functions and notice that when we see these things, we'll know exactly what they mean, and that we're going to evaluate the inner function first and then use that answer or use that function into the outer equation. So no matter how you see this, so g of f of x or g of f of x, we have kind of this nested function, and that we're always going to work our way from the inside to the outside, just kind of like how we do with parentheses. But compositions are another way that we can substitute functions and also create new functions outside of that and kind of have them create something new. And so that's going to do it for this video.